Yeah, so I just want to start thanking Ethan for the invitation. It's really an honor to be here, and I love the name of this organization, Community Stack, because really, it goes to the heart of something I very much believe in, and I think you can see is true, that really when you bring together technology and the community around the technology, that's when magic happens, because technology just on its own doesn't do anything. And it's when you bring that welcoming and inclusive community that ideas get created. And in fact, that's how we got the revolution of cloud native, and that's how Kubernetes came to be. In fact, I don't know if you remember, pretty close to here, just down at CodeNode 10 years ago, we had the very first KubeCon in Europe. And actually, hands up, anyone who was there? Me? I'm the only one? Okay, maybe a few of you are still in school then. But in fact, I found this picture on the camera roll of that. So very similar kind of scale of event to this. And from that, the KubeCon that we know today grew. And in fact, back then, it wasn't even clear that Kubernetes would be the standard platform for container orchestration that it is today. I remember there were the orchestrator wars. Would it be Mesos? Would it be Docker? Would it be Kubernetes or something else, or Nomad? All these things, right? But what you see here is, why are we growing so fast? Platform, so a combination of the stack, what is the tech, and community, and that truly is what made Kubernetes successful. And I believe this community here can be part of that, and we'll see that throughout the day today. If we also go back to that first KubeCon in London, we just announced Kubernetes 1.2, and there's a whole load of things that got announced at that point. One of them was a new UI. So this was the first time that Kubernetes has actually had a web UI, which was called Dashboard. Now, we've continued to invest in Kubernetes, addressing scale challenges, auto-scaling, horizontal pod auto-scaling, vertical scaling, stateful workloads, which weren't around at that point. So all of these things have driven adoption. And today, in fact, I don't know if you've seen this, there was a report just came out from CNCF. They estimate, this is Slashdata, so an independent analyst organization, estimates there's 20 million developers using cloud-native tools today. And that's more than doubled over the last year. So it's an incredible pace of growth that we're seeing, a lot of that driven by AI. But how has the user experience even changed? Because as we think about the kind of users that were coming on board, sure, we're going to have experienced developers. Kubernetes has always been driven by system administrators, Linux developers who are very comfortable with kind of the maybe slightly harder edge of usability. But we're going to get more hobbyists, more students, as this is the standard platform. Students coming out of college are going to be learning on Kubernetes. IT admins who may be more used to a Windows kind of experience are going to be using it. And what's their user experience going to be like? So what do we mean by user experience? Really, and this is straight from Wikipedia, done the presenter's easy path, right? But it's how a user interacts with and experiences a product, and it includes your perceptions of utility, ease of use, and efficiency. So it's not just, does this thing work, right? But how do I perceive it? How's it come across to me in terms of the ease of use? And a lot of that is kind of that first experience. Because if I said to random person on the street, hey, there's this cool thing, Kubernetes, go install it. They're going to, if they're on Linux, if they try and do an apt-get, or they try and do a brew install, or they go to their app store, they're not going to find a Kubernetes app. So it's pretty clear it's not just like something you just go install like you would install a new web browser. And in fact, that typical user journey, if they do work out how to get it installed, then it's primarily going to be a command line experience, right? You're going to see kubectl apply, and you've got YAML to deal with, and Helm charts, and you've got whole books telling you how to do this, and you'll see some incredible evangelist up on stage typing kgetpo, and like, what the hell does that mean, right? And this is all pretty confusing. and pretty intimidating. And that's just Kubernetes. On top of Kubernetes, as you know, you have a whole lot of projects. You've got to think about what am I doing for networking, what am I doing for storage, increasingly now AI stacks that you're building on top, ops, all these things, right? So each of them has its own installation process, each of them has its own user experience. And back in 2018, we tried to make this easy for people by defining the cloud native trail map, which was suggested path for companies that want to modernize their infrastructure. But nobody's using all 16 CNCF projects as part of their enterprise computing stack. Can you imagine 16 projects to choose from? It's changed quite a lot since then, right? And the complexity of this landscape, of this ecosystem, has become a meme, unto itself. So yes, it's a rich, diverse ecosystem that's being built around Kubernetes and being, that makes up the cloud-native world, and that's fantastic, right? We all like choice. We all love to have things to choose from. You don't want to be told this is the one and only way to do networking because maybe there are different scenarios, or maybe same for storage, right? So choice is good. And actually, speaking for Kubernetes and kind of the ecosystem and how we built it, there is a lot of consistency. So we added the ability to provision third-party resources, now called CRDs, in Kubernetes back. I think that that was back 10 years ago at the KubeCon code node, and that's created a standard way for provisioning applications that are built on Kubernetes. The fact that everything now standardizes on YAML, and there's a controller pattern of having basically an application that deploys into Kubernetes that's controlling deployments and Helm charts. So all of these things do create a kind of a consistent feel to most cloud-native projects. And of course, in many cases, you want a separate user experience for a different project. So a user experience for a storage project is going to be very different from a security project, right? And necessarily so. And you want to be able to develop these kind of solutions on independent paths. So yeah, it's good that there is some kind of loose association between them, and we're not tying them all together into a single application. So that is all goodness about having such a rich and diverse ecosystem. But I'm sure you can see the downsides of it, right? Particularly for newcomers, right? The learning curve of getting up to speed, from zero to running a production Kubernetes environment, worrying about all of these pieces that you have to put together to make it not just performant, but scalable and secure, right? And actually functional, right? That's a lot to learn. It takes a lot of time. It's not friendly to newcomers. There's a lot of context switching that you're going to do. I'm thinking about maybe, Rook. I'm deploying Rook for storage, and then I'm deploying Calico to do some networking, and I'm switching between these things. That's in and of itself consuming a lot of cycles and can impact your productivity. And there's inconsistency between these tools, right? So sure, maybe they all use CRDs, but each of them is defining their own one. There's a whole, maybe different projects addressing the same area do it in slightly different ways. So that's definitely a downside of all of this kind of fragmentation. So this is kind of, I think, what new users are left feeling like. So there has to be a better way, and particularly if we think we've grown to 20 million, how do we expand to the next scale beyond that initial 20 million? And one answer might be, look, we have managed services. This is what managed services do, right? If you go to Amazon or Google or Microsoft, right, we have managed Kubernetes services that package with an opinionated stack, and you just say, deploy me a Kubernetes cluster, and it takes care of most of this. And that is true. I would say it takes a lot of work off of your plate. Being from Microsoft, I would say, of course, AKS is fantastic. Of course, you should use that. But the point is, from a community perspective, we still have to think about what is the upstream experience. And I'd love to see us doing more in the upstream world to address some of these user experience challenges. And if we think back to, I'm old enough to remember using computers where it looked like this screenshot on the left, right? Having my floppy disk with my personally curated config.sys and autoexec.bat that was, precious to me. And people loved doing that at the time, but that isn't what drove the mass adoption. The mass adoption of computing and internet happened hand in hand with the rise of Windows and user-friendly graphical UIs. So, I would contend that this is the path for us for a user experience for Kubernetes to make it a lot more accessible. So what would that look like? Well, there's a few things. So first of all, we'll always want that web dashboard experience, right? So take that Kubernetes dashboard and continue it, take it forward. Increasingly, we want to be able to manage multiple clusters. So there's complexity that comes out of having a fleet of many clusters, and how do you pull that view all together? And I think a local desktop application is super powerful as well. I mean, we've seen this with Docker Desktop. Why should we not have a Kubernetes desktop that's just as easy to use, which is part of that Kubernetes experience? And more than Kubernetes, the whole cloud native experience as well, embracing all of these technologies. So we want a web portal. We want a unified management UI. We want a desktop project. These aren't three separate projects. They should all be one. And we actually have a project today called Headlamp. And in fact, I don't know if any of you were at KubeCon last year in London. Show of hands, anyone was there? Okay, so I talked about this there. And we just announced at that event that Headlamp had just moved into the Kubernetes upstream project. So this is it was an official UI project of the Kubernetes project. And in fact, since then, the SIG UI, so the user interface special interest group of the Kubernetes community, has deprecated the original dashboard, and this is now the only UI that's actually part of Kubernetes. So it kind of provides a single point for folks to work on. And so it has all these things. It has the modern web UI. It has the local desktop application, does multi-cluster management, all of those kind of things. Looks something like this. So this is just a graphic from the website, so you can go and check it out. So, aesthetics is very subjective, but for me, I think this is a nice, modern, clean, fast, zippy experience. And got all the things you want at the tip of your fingers. And remember, this is open source, part of the upstream project. This is not like a commercial product that anyone's selling. But one of the nice things about it is it has a lot of extensibility, right? So you can configure everything in this. It's super easy to build a downstream application based on Headlamp that has your own branding, presents things in whatever way you want, and a lot of extensibility points. So in fact, at Microsoft, we've done this. You'll see we've announced a product called AKS Desktop, which is just a reskinned version of Headlamp with a whole bunch of Microsoft-specific workflows and things, and actually, some features removed, some added, but it's fundamentally the same technology underneath. So I think this makes, for us, it's a nice differentiated capability that we deliver that makes it, I think, the easiest on-ramp for users to use a managed Kubernetes service. But end users can do exactly this for their own internal teams. In fact, in Microsoft, we have an internal developer platform for folks like the Office, Microsoft 365 developers and teams and all those folks to be able to deploy onto Kubernetes, and that uses an internal web portal which is based on Headlamp as well. So this is really nice, and it's the plugin architecture enables this to be done without having to fork a downstream project, so to keep it in sync with that upstream. And while Microsoft has embraced it, obviously most of the development originally came from our team. It's now been, this is a word cloud that someone on the team made of all of the contributors into the project over the last 12 months. You can see it's been embraced across the industry. So I'm pretty proud of how, over that last 12-month period, from going from zero, going into the Kubernetes UI SIG to today, that we've really managed to build a really thriving community around it. And in fact, the plugin community is super strong. If you go to CNCF Artifact Hub, so within Artifact Hub, there's a special category now, Headlamp plugins. You can see there's nearly 70 or so plugins published there, and people can build their own without publishing there as well, of course. And pretty much every project you might want to use is represented there. So we're pretty excited about what that does to bring together that unified experience. And now that user doesn't have to think, oh, how do I deploy XYZ from the landscape? I just can go within Headlamp, go to the plugins tab, discover from Artifact Hub, oh yeah, there's the project I want, click that, and it's deployed into my cluster. So that's Kubernetes user experience. This is the cloud native and open source AI talk, so you're not going to let me off stage without talking about AI a little bit. And because the future of Kubernetes is not just about how do we evolve the user interface, it's also about how do we evolve the workloads that are running on Kubernetes. And increasingly, those workloads are AI workloads. In fact, this is also out of that CNCF survey. Kubernetes is now the primary platform for people running AI workloads. So that's why we're talking about it in the context of what's happening today, right? So 2/3 of the respondents to this survey were using Kubernetes for their AI workloads. It turns out there's quite a wide array of those kind of applications, from fine-tuning, training, just experimenting, inferencing, etc. Right? But what I think is probably going to be the biggest impact for certainly most developers and users in kind of enterprise settings is going to be what happens when you start to run agents within Kubernetes. And this was a report came out from Gartner just recently about how they see agentic workloads growing from right now. They suppose something like 5% of workloads had some kind of agentic capabilities. They're suggesting that's going to go to 40% by the end of 2026. Now, that's only 6 months away, so that we're on quite a curve here, and that's going to go through a whole journey. Just 3 years away, they're saying this will be the new normal of enterprise applications. In fact, I suspect by 2029, people will be looking back at us today saying, what are they talking about, all agentic stuff? This is just apps, right? The word agentic probably goes away because, well, that's just how we do things. That is the new normal. So we need to think about how do we get from here to there. And the elephant in the room around agents is the security risks and the challenges of it when you give OpenClaw access to your bank account, to your crypto wallet, to your email, inbox. I love this. Keep looping until we've cleared everything out of your inbox. Stop, OpenClaw. No, okay, and I remember I violated. I know you told me not to do that, but oops. You're seeing stories like this all the time. And a lot of this is kind of consumer applications, right? But if you're an enterprise CEO seeing these stories and you're thinking, how does that translate into deploying an agent in an enterprise environment, you're going to be pretty concerned. In fact, this is a survey by McKinsey, and they found that among IT leaders in enterprises, security risks and concerns really are the main obstacle to deploying agentic AI, right? So they know that they wouldn't give their toddler the keys to their Ferrari, right, or the Mercedes, but and equally they're not going to give the agent their keys to the enterprise data store and the entire email history and all of this, right? But you have to be able to let it do some things. So we've been working on this kind of problem, and in fact, I'm going to bring Pal on stage, my colleague who's been working on a lot of the agentic frameworks. So Pal, do you want to come up and join me?
Great, thank you, Andrew.
Do you want to use that? Or?
Yeah, thank you. You need that, or I can?
No, you take that.
I can take this. Hi, everyone. Thanks for coming. So as Andrew mentioned, toddlers, just like agents are just like toddlers. Toddlers do need sandboxes, and agents do as well. And so at Microsoft, we have done quite a lot of open source contribution to the different communities and have some interesting projects we have created. I hope I'm audible. Some of these are highlighted here. One of that is being the Microsoft Agent Framework. That kind of gives you the similar experience to like LangGraph, LangChain, or Pydantic, or some others, basically. The second one is a more recent announcement. It's called Microsoft Agent Governance Toolkit. And that basically is quite a complete set of capabilities which you could potentially include into your agents, which helps you to govern even from the code level. So, for example, inspecting different tool calls, denying the different tool calls, and defining basically policies across the whole agent lifecycle. And then the last one is a very recent. We have not officially created a blog yet about it. It's just kind of soft launch yet. But it's called the Agent Reference Stack for Kubernetes. And that's built on top of using Agent Governance Toolkit inside. So it's kind of like a reference implementation how you would potentially want to use the Agent Governance Toolkit in your environment. But it's also giving you a ways to basically orchestrate your agents at scale on Kubernetes, both on-prem, like using like a kind cluster in your development environment, or, for example, on AKS with a proper and widely integrated into the Microsoft or other ecosystems potentially. So using Entra Agent ID, AKS, etc., etc. So, and then basically the demo is going to be about the Agent Reference Stack for Kubernetes. What does it give you? It's a Kubernetes native runtime for AI agents, which is going to give you fleet management. So basically you can deploy your agents at scales because everything is driven through CRD and Kubernetes native primitives. It gives you an execution sandbox environment using OS native and other set of capabilities to basically contain the agents to run in a, well, let's say contained environment, but still being able to execute its harness to achieve the task it's supposed to achieve. Additionally, it's using from the Agent Governance Toolkit things so-called Agent Mesh, which is built on top of Signal protocol, the same which the Signal application is also using, enabling agents to be able to establish end-to-end encrypted communications. So, and then lastly, there is an inference router which is part of the whole deployment, which is responsible for the whole governance and policy establishment for your sandbox itself. So let's get to the demo. And maybe the outcome is going to be that I can half-handedly manage agents on Kubernetes because there is no other mic. First of all, just a quick overview here. I wanted to show you something interesting, which is how you define the agents. So this is exactly what Andrew talked about, the YAMLs and how you apply it. So that's just for the sake of understanding. So you have different CRDs. The inference policy itself is a CRD, so you can apply an inference policy at scale to hundreds of agents, for example, including budgets, including which, for example, model providers it should be using. So, for example, if you want to change a model provider for your agents at scale, you can just simply edit a single CRD, and the controller is going to reconcile that according to your settings. There is a tool policy, and that is actually the definition of the AGT-driven policy. You can see here there are some tool allowed actions. Basically, those are the only actions which is actually allowed. And there is actually the car sandbox, and the car sandbox is the unit of your agent. So that is going to be reconciled on Kubernetes as a pod, including everything together. So let's just see how does it work in practice. So here I have a local Kubernetes environment set up with all the different environments, and this is the live headlamp, and it's going to be a live demo, so not a recorded one. And so this is basically I'm just half-handedly deploy these agents in a second. Not this tab. Apologies for that. a different tab. I think I just need to go a bit outside of this folder for a second. Oh yeah, that would help a lot. I think, okay. So I'm going to deploy these agents. And basically, you're going to see on the headlamp cluster in a second that some of these agents actually coming up. So it's going to deploy 3 different agents, a translator, which is going to be probably the most interesting, the analyst, and the last one. You can also have like a cars plugin we have written for headlamp actions, so you can have an overview of your running agents, which is basically you have 6 sandboxes in total. And you can see the age, because I just ran that program, so it's 26, 27, 28 seconds ago they are just running basically. And the analyst is Hermes-based agent, the translator and summarizer are, one is OpenClaw and the other is Hermes-based. So what I wanted to show you that after, so let's just connect to the translator. Thank you. So it's going to establish you a connection to this one I wanted to. So hi there. I'm just quickly chat to it. And you're going to see that it's going to introduce itself. It's out of the box integrated with a Foundry project. Obviously, when you run a dev mode, it's integrating through an API key. But otherwise, when you run it on AKS, actually, it's using Entra Agent ID and federated identity or workload identity to get access to Azure resources. So you don't actually have to give any kind of API keys to the agent itself. And if I want to ask you, could you, thank you, please generate an image using Foundry image generator about a dog. And so I tried, but it says that the sandbox is blocked tool by a tool policy. So basically, you can see that it was blocked by an AGT policy. And actually, I have a operator view of the car sandboxes as well. So it's up to you which one you want to use. It's more like a TUI style representation of your deployment. It shows you the different agents you have deployed. And you can actually see that the translator was being also rate limited, but also you can see that there is like 0.7% deny. But if you want to go back to the actual headlamp view and check your translator, you're going to also have some nice Grafana dashboards, and it's also going to show you that actually about different, so there is the block for the actual AGT policy decision itself. So you can see there is one block happen. So that's pretty much the sort of the outskirts, or like how you use the agents and how you use the cars to spin up agents. It's quite, there's a lot to tell about it, and it's quite a big project, so you can do quite a lot of different things with it. And here's the project, so you can go through on it. But let me get back to the presentation. So obviously, there you go. So after the demo, so obviously AI won't just run on Kubernetes, but for some of the use cases, such as, for example, if you think about an SRE type of use case, an agent could be equally a user of Kubernetes. So the presentation is also about how are we going to make Kubernetes to be also enabled for agents to be able to communicate with it efficiently and securely. And so some example from Microsoft, we also use internally. We have a code name called AKS-Claw. So as you know, Kubernetes is a managed service. So each of the engineers in the engineering team who is managing Kubernetes, they have their secure agent sandbox called AKS-Claw, which could be leveraged for SRE purposes, helping our team to work more efficiently and finding things. So such as, incident triaging, troubleshooting guidance, and it has also some telemetry access to our internal telemetry system, so it's quite efficiently able to query through those channels. So what changes when the user is an agent? Obviously, there are requirements to be able to talk as an agent to some form of system through machine-readable or machine-defined interfaces, because the agent is not going to click around, although it could probably do that as well. Scale, automation, and obviously, I think one of the most important aspects is policy and governance. So you want your agent to be controlled. You want your agent to be able to autonomously do the job without being or going sideways, basically. So I think that's quite the most important balance when it comes to securing agentic environments, is because the agents require autonomicity to execute the harness internally. However, it also requires something which is able to sort of control them and those tools which the agent tries to use, or some other areas which the agent tries to go, ideally maybe hallucinating something or trying to go sideways. So policy and governance, I think, is quite important. So a couple of examples of how we are also trying to help the community of enabling the different systems and environments to be able to agent ready for being able to communicate it by or used by agents. So there's Kubernetes, Azure Kubernetes MCP server, as well as there is an Inspector Gadget MCP server. How many of you are familiar with Inspector Gadget, by the way, just out of curiosity? It's a toolkit. It's a really nice way to enable eBPF for multiple different use cases, from security to monitoring to troubleshooting on Azure Kubernetes service, and also it's used in some other Microsoft products like Microsoft Defender for Cloud. So therefore, the second demo comes when I'm going to showcase, so coming back to my cluster here, this is my cars cluster, and basically I have here like an SRE window for it. So I'm just going to say there is like a special SRE agent deployed as part of the cars thing. It's called, you can also query status. So you can see that it's actually deployed. So it's in a different namespace from others, and it has, through the RBAC controls, some different setup. But hi there, there you go. Hi there, give me, could you please, sorry, give me a summary of my cluster health. So we're going to see it in a second, grinding a little bit and using a little bit of tools which are baked into that. So throughout those built-in channels, it's going to call some of those tools. So it's going to say that overall, your cluster is actually healthy. This is all live, as I mentioned earlier, so it's, there is a little bit of the waiting time it requires, but pretty much that's how our current cluster feels like. We could verify it through the UX, but I don't want to spend too much time on that. I think what's the most important, which I'm gonna do that, I'm gonna break my research agent. The way I'm gonna break it is basically quite a common Kubernetes mistake, or maybe DevOps mistake. Essentially, a resource quota policy is going to be applied not on a single resource level, but on a cluster level. So once the pod is going to be restarted, it will try to come up, but it's not going to be allowed to take the resources it requires. So the agent is going to be down. By the way, Andrew suggested me to ask if everyone is comfortable with using CLI a little bit. So I'm sorry for not asking that earlier, but it's just for me breaking the cluster and also triggering a state of agent change. What also happened, you can see that the research agent became unavailable. And if everything also works, I'm not sure if you can see, but at 10:36, I cannot put it on the screen, but I receive an alert through Telegram saying, oh, there is a research agent went down. So what I wanted to show here, coming back to our previous chat, is basically here. So I'm going to say, oh, thank you. Could you please check again my research agent, oh, sorry, agent is down. I hope it's gonna, the algorithm will parse that as research if the weights are in the right place. And so it's going to analyze a little bit as well, and not only gonna identify that actually the agent, the resource agent is down because of that resource quota issue, but it's actually going to propose a fix. And that fix itself is going to come up in a second in the console once it's did its job, hopefully. And based on that proposal, the operator can actually either approve that or deny it after reviewing. Also, the actual proposal comes as a YAML, as a CRD, which the controller is able to fix. By the way, every custom resource definition as part of the CARS framework is going through an assigned and audited, attested way. So the CARS controller itself is responsible for doing that attestation for each of the signed change you apply. That also applies to even egress policies, for example. So let's say your agent wants to egress to some network domain. Even the egress policy itself is a signed and attested entity, and you as an operator have a chance to add additional domains even for like an hour or 15 minutes, for example, as an OCI signed artifact for that chain. So it's still thinking a little bit. Maybe it's the network, but I think soon it's going to figure out. Oh, there should be. Oh, let me just check. Yeah, that's the live demos. Okay, can you just can you please? Okay, my research agent is down. Maybe let's be more aggressive with it, and then see. Hopefully, 10 out of 10 times it worked before, so that's the 11th, which it's gonna give up. So, okay. Let's just see. Oh, I think it's gonna. Get it now. So okay. So and in the meantime, what? Okay. Yes, there you go. Thank you very much. It's found the resource quota related issue, and it's also proposed a fix. And basically, that fix is proposed as like an individual UID. It has that fix. So if I go to the console, you can see here the same UID. It says SR reaction FG949. So you can actually overview what's the actual fix it's proposed. So if you go back and say, OK, I'm going to approve this fix, it's going to wait for the recovery. And once the controller sees the signal of the reconciliation after the fix was applied, our research agents will come back to normal. It typically takes a couple of seconds, hopefully. I'm not sure how we are going on. We are OK. So that should do the job. And maybe in the meantime, while it's doing its job, I just wanted to show one additional thing which you might find interesting. So I'm going to disconnect this from the translator, and I'm going to connect to my dev agent, which is not that restricted. OK. So that's a different agent. OK. Could you please do that? Thank you. So hi there. Could you please spin up a sub-agent and talk about it with today's news? Yeah. Sorry? Sorry? Yeah.
You can make spelling mistakes, yeah.
Yeah. It's okay. It's going to be recorded, so I like to be precise. But, okay, so as you can see that the nice part is that it's using the cars. So for OpenClaw, we are denying the built-in hooks called session spawn and session send by the native configuration. And through the cars plugin baked in, we offer a capability to actually do the sub-agent spawn through as a CRD reconciliation, basically. So when you go to the mesh topology, you can see that the dev agent just spawn up that news brief agent actually. And basically, it shows that the communication is ongoing or down. There is also like a table format. It's important to understand that each of these agents holds the session. So every communication between these agents are end-to-end encrypted. Plus, also, when you run on AKS, all of the agents are also assigned with an intra-agent ID. And in addition, of them being end-to-end encrypted, there is an isolation mode confidential for each agent. So if you're aware or familiar with AKS pod sandboxing, which we recently announced, you can have a chance to, when you in a CRD say, I want an isolated, confidential isolation level agent to be provisioned, it's going to be provisioned on a kata node pool, which is going to run a confidential container, meaning even if an agent would attempt an escape from the sandbox, even bypassing all the different capabilities I just showed you, seccomp, etc., the boundary of the VM would be still not basically impacted because of the pod sandboxing and the way the kata containers are actually securing that VM boundary inside of AKS. So just coming back to two things. So this is the news brief, and basically you can see that the discussion and it's sent. So basically that's the AMID, it's sent, and so on and so on. And basically here is a discussion between sub-agents take away, today's biggest teams are blah, blah, blah. So that's happened through an end-to-end encrypted protocol. And coming back to our cars cluster, so if I go back to the SRE view, well, my workload is still down. I don't know why. It's still waiting for recovery. Well, I think that should at some point also come back. Not sure. Let's just check it. It might be just something didn't get refreshed. No, there are no pods. So, all right. I'm not gonna exhaust more the demo, but it's also as part of the sort of the cars thing, through the inference policy, you have like a fleet buys token budgets. You can see how each of them individually consuming. And obviously, because of the way we govern them with this inference router just directly deployed into each of the sandbox. So I can show you, for example, one sandbox, just simply how it looks like. Let's say showing the one of the running sandbox, for example, not the research one, but the translator. You can see that it consists of a pod which has two containers. So one container is the actual OpenClaw with quite a lot of different things assigned, and there is the inference router. And so the way it works is that when we provision these two, there is also like an egress guard init container gets provisioned, which injects very strict IP tables rule into the OpenClaw. So the only way of egress path to leave the network is through the inference router itself. So I think that's pretty much it. I think that SRE action, that's failed. Okay, so I'm not going to go through on another. Oh, but in the meantime, it actually came back. So there was a bit of apologies for that. I guess we can consider it as part of the live demo. But if I go also to the operator view, I can see that my research agent is up and running now since 46 seconds. So it did gone through, and there was a little bit of a hiccup. But I think that's pretty much what I wanted to show you when an agent is actually the user of Kubernetes. And then back to you, Andrew, for the
thanks, Pal.
closures. So thank you very much.
Appreciate including that little hiccup just to prove that it's live, so you know it's not a video. So just to bring it back to like where we started, I think it should be obvious by now that we see the future of agentic AI being built on Kubernetes, being open source based, right, and being built in the open and driven by the community, right? So that's super important, and everyone here has something to contribute to this. It might be participating in the upstream forums like the AAIF and the CNCF and those working groups, or it might be writing code, contributing, starting new projects, or just contributing your real-world use cases and bringing your experience to the discussion of trying out these technologies. And thank you again to Ethan for creating this forum where we can have these conversations. So thank you very much.